All right, so hi everyone. Today we're going to talk about wave and tidal energy. So tides are generated by the gravitational pull of the moon and the sun, and they are capable of generating large amounts of energy that can power up to a third of the US, making it an efficient source of renewable energy compared to many others, as shown in this graph. So tidal energy has been used for a very long time, and technology has evolved as well. So older technologies use dams and turbines to generate electricity by holding water from the tide and passing it through a turbine in one direction. However, newer technologies such as the one shown below do not use dams because they are costly and can harm the environment. Instead, they use in-stream turbines with axes that are horizontal and vertical that can pass water in both directions by opening and closing ducts. Energy gained from tidal waves are then converted into electricity using rotors and magnets.
So there are three main types of tidal plants. The first one being tidal barrages. They look similar to dams, but they work in the sense that the tides move the inner turbines within the system. And then there are something called sluices, which are water gates, which are incorporated to control the water level and the water flow. The water gates open as the water level rises, and at low tides, the sluices close, and the water is carried out by the turbines. There's a generator connected to the entire system to generate electricity. This type of tidal plant is the only kind that is in operation in the world currently, the largest being in Siwa Lake, and the other largest being Lorance, which I will show pictures of later. They can help the environment by preventing flooding since it controls the water flow, but the drawbacks are it can harm marine life by changing the quality of seawater. Tidal turbines is another kind of tidal plant. It's similar to wind turbines, but they're placed underwater, and they can also capture more energy than wind with the same size blades. They have to be also sturdier than wind turbines since water is more dense. The way it works is that water current pushes the blades of the turbine to generate electricity. They tend to move slower, so it doesn't harm marine life as much as tidal barrages do. But it still does disrupt the environment due to noise and collisions with the environment. There are different tidal turbine projects in development in the US, including in New York and Maine. The last main kind of tidal plant are called tidal fences. They are vertical turnstiles which are arranged together as in a fence-like structure, and they're pushed by water current. They're seen as a combination of the barrage and turbine system since it looks like many tidal turbines connected together. They're usually installed in between land masses and are completely underwater. They're less expensive than tidal barrages since it does not control water flow at all. They're placed in fast-flowing waters to take advantage of the kinetic energy of the water. And there are currently no tidal fences in operation yet.
So using tidal energy as a source of power can greatly reduce our impact on the world around us. Tides are reliable, and we can predict when they are the strongest and weakest and are available 24/7. Converting tidal power into electricity is mostly a physical process rather than chemical, so as a result, no harmful byproducts are produced from this energy source. So here's some of the benefits of using tidal plants. As I said before, tides are predictable, renewable, and do not produce any emissions, and they're more powerful than wind turbines because water is more dense than air, and tidal power plants can last for 100 years. Tidal energy also produces a lot of power, as 120 to 400 gigawatts are available from the total of 3,000 gigawatts that can be produced from tides, and this makes it capable of producing up to 3,800 terawatts per year.
So one of the requirements for harnessing tidal energy is the cost, and that is a significant setback to this solution since it is the most expensive of all the renewable energy. Previous tidal plants have costed $516 million and $980 million, and these costs are referring to the two tidal plants Siwa Lake in South Korea, and Lorraine's tidal plant in France, which are shown in the slide. According to the Drawdown website, current predictions for the cost of tidal power plant is $1,837 per kilowatt in 2030, which is comparable to $1,786 per kilowatt for more common sources of energy.
This solution is still in its beginning stages and has been implemented in countries such as Korea and France, but there are no current tidal plants in the US. There still needs to be research done on the negative environmental impacts of tidal energy, such as how it impacts wildlife, because we only have theoretical evidence at the moment. One of the limitations of wave and tidal energy is that power potential depends on wave height, wavelength, and water density. Power distribution also depends on coastal proximity, which can be an issue for less populated areas but benefits densely populated coastal cities. Another limitation is that salt water can corrode tidal plants over time. Tidal plants can also disturb the seafloor, altering habitats of marine species and possibly disturbing vessels and other boats, which can lead to legal issues. It can also harm sea life from non-direct effects such as sound pollution and the release of toxic chemicals. One of the biggest limitations is that it is the most expensive renewable energy source. Along with this cost, the net carbon dioxide reduction compared to other renewables is much less. It is projected that tidal power will save $1 trillion by 2050, which is less than other renewables, but this money will go toward the expansion of tidal power in new areas. The cost of tidal energy may outweigh the benefits because it is more selective in terms of location and infrastructure than other forms of renewable energy. To summarize, tidal power is a reliable, predictable, and powerful form of energy production with positive environmental benefits. Despite its costs and other site-related limitations, to respond to the criticisms, it may be important to still develop and implement tidal and wave energy in new areas as the need for renewable energy only increases.